Okay, so this is part 2 of this problem. So same punter, it kicked the football in the air. Here's your projectile path. Now it kicked it at a 60-degree angle, and it was at a velocity of 25 meters per second. Now the question is this: how much distance will it take this? What is the range, right? So how far will the ball go in the horizontal direction? So what is dx? What is the distance in the x direction that this ball goes? Now, again, every problem you have to kind of break this down into the x and y components. So what do we know in the x? What do we know in the y? Well, what we know in the y is that the acceleration in the y is negative 9.8 meters per second squared. We also know that the initial velocity in the y is 21.6 meters per second, and the way I found that was 25 sine of 60. The final velocity in the y is negative 21.6 meters per second. Time we found in the previous video, and that was 4.42. If you're not sure how we found time, I'm going to redirect you to that video. Okay, so I will redirect you to that specific video regarding time. Okay, and then the last thing is distance, or the displacement in the y, I should say, is 0 meters. Alright, so let's move on into the x. What do we know in the x direction? Well, acceleration in the x is 0 meters per second squared. Initial velocity in the x direction, that is 25 cosine of 60 degrees. Initial velocity, or final velocity in the x direction, since acceleration is 0, is also 25 cosine of 60 degrees. Time is 4.42 seconds, and then distance in the x direction is what we are trying to find. So that is our mission for this problem. Alright, so just kind of scrolling down here. So here, I mean, you already have enough knowns where you can find that, right? And again, time was found in the previous video, so if you make sure you kind of go to that link, watch the video, it's part 1. Okay, so now all we have to do now is kind of using initial velocity, distance, time, and acceleration, which equation would we use to kind of find that dx? Well, the equation you use is distance is equal to initial velocity times time plus 1/2 at squared. Well, acceleration in the x direction is 0, so that whole term goes away. So you're left with distance in the x is equal to initial velocity in the x times time. So distance in the x is what we're looking for. Initial velocity in the x is 25 cosine of 60 degrees, and then time is 4.42. So 25 cosine of 60, that number is 12.5. And then you're going to multiply that by 4.42, because that's your time, to get a total distance of 55.25. So 55.25 meters is equal to your dx. Awesome. If you guys have any questions, feel free to email me.